Hi, this is Nat, and this is going to be a video lesson on how to use the distributive property to simplify variable expressions. This is a super important skill to have. Distributive property comes up a lot in mathematics, particularly when it comes to solving equations. And some equations you can solve without using the distributive property, but there are some where you absolutely have to be able to use it. And we're going to talk about what it is, how it works, and we'll get some practice on how we actually go about using it. So what is the distributive property? Basically, the distributive property tells us that if I am multiplying an operation in parentheses, usually an addition or subtraction operation in parentheses, by something outside the parentheses, for example, here we see 2 times the answer to 3 minus 7. If I'm doing that, it is actually the same as if I were to multiply that same thing by each piece individually. So again, here in this example, we can see that here, instead of multiplying 2 by the answer to 3 minus 7, I'm multiplying 2 by 3 and subtracting 2 times 7. So what I've done there is I've actually done what's called distributing my multiplication. I distributed it to everything inside the parentheses. And we can actually prove that this is true right here. Because if I do this according to order of operations, 3 minus 7 is negative 4, and then times 2 is negative 8. And over here I can say, well, 2 times 3 is 6, and that's minus 2 times 7, which is 14. And 6 minus 14 again is negative 8. So we can see that, in fact, those actually are the same things. The distributive property is actually a really nice tool for mental math. If I have to multiply something like this, let's say, 8 times 52. And you're going to notice I'm writing my multiplication as a number sitting next to another number in parentheses, and that's a common way that you'll begin seeing multiplication. So we're going to practice with it today. So 8 times 52. So instead of solving 8 times 52, where I might need to write it out or use a calculator, the thing I learned from the distributive property is I could treat that as 8 times 50 plus 2, and do each piece individually. 8 times 50 is going to be 400, and 8 times 2 is going to be 16. So without a calculator or any sort of computation on paper necessarily, I could have done that in my head. 8 times 52 is 416, because 8 times 50 plus 8 times 2 is 416. And that's kind of a mental math way of using the distributive property, and you may have seen that before. It's nice to know that kind of works both ways. For example, let's say I'm trying to multiply 7 times, 48. Well, again, I can rethink what 48 is. I might say, well, 48 is a lot like 50 minus 2. I don't have to do 40 plus 8. I could think 50 minus 2 is also 48. And then 7 times 50 is 350, and 7 times 2 is 14. So 350 minus 14 is going to be, 338, right? Oh, no, 14, so 336. Maybe not quite as easy as the adding thing sometimes is, but it works pretty well. So that's sort of the gist of it. That is distributive property used for constants, real numbers that we're looking at. While the distributive property is really important to know and really nice to know for numbers, it's absolutely essential once you start working with variables, because there are equations you can't solve and expressions you can't simplify if you don't know the distributive property. So we're going to be focusing in on what that looks like with variables for the rest of the lesson. Let's say I have the expression 3 times x plus 4, where x plus 4 is in parentheses. I can again use my distributive property to simplify this, which in this case means getting rid of the parentheses. Parentheses can really mess up an equation in terms of what I'm able to do with it, and sometimes getting rid of them is the best thing. And I can always get rid of an expression like this or at least the parentheses for it, using the distributive property. So I can say 3 times x plus 4, where I'm going to multiply the 3 by x and the 3 by 4. Well, 3 times x is just 3 x's, and then 3 times 4 is just 12. So where I have a variable, I'll just kind of put it next to the variable. That means multiplying without actually multiplying. And where I have a constant, I'll go ahead and multiply the constant. So 3 times 4, 12. Here's another example. This time it looks pretty similar, but I put a 4x in instead of an x by itself. So this time the x is already being multiplied by 4. Doesn't really matter. Still just going to multiply in that 6 to get rid of those parentheses. In this case, 6 times 4 times x is just like 6 times 4, which is 24 times x, so 24 x's. And then 6 times minus 8 is minus 48. So again, pretty easy little simplification there. Just have to multiply it in. It's kind of nice to know that you don't need numbers at all to make this work. So here I've got a expression with just variables. And again, I'm just going to multiply that a in. A times b is just ab, putting them next to each other. It just means a times b. And then a times c is just going to be ac. And I've gotten rid of those parentheses. AB plus AC is the same as what we started with. Now, it's really no different, but the thing that starts to mess kids up is when you start dealing with negative numbers. So let's throw in one with some negative numbers. The important thing is whether or not, if you look at that 2, whether or not it's a negative 2 or a minus 2, you're going to treat it exactly the same way, which is as a negative. And I'll show you an example of where people sometimes make this mistake in a minute. But when it's just a negative, you multiply like it's a negative. So negative 2 times negative 4 makes positive 8 x's. Negative 2 times positive 3 makes negative 6, or minus 6. So if you kind of ignore those plus signs like we were talking about in our like common terms video, it'll kind of work the same way. What we care about are the negatives and the minuses. They matter. The pluses really don't. And the thing we really want to kind of get out of this is that it pairs really nicely with the idea of combining like terms in terms of simplifying an expression. Here I've got a combination of both. In the middle, what we want to start doing is recognizing that distributive form, that idea of a number being multiplied into a parentheses. So I can go ahead and do that part and then simplify the rest of the equation. So 6 times 2, 6 times negative 8. 6 times 2 is 12 x's, and 6 times negative 8 is negative 48. And if I just go ahead and put the rest of that back in there, the plus 7 and the 3x, I now see something that looks a lot like what we had in the last lesson of combining like terms. Hopefully we notice or remember from last time that 3x and 12x are going to be like terms, and if I combine those, it's just 15x's. Similarly, negative 48 and positive 7 are going to be like terms. And since those have opposite signs, they cancel each other. So it's actually just going to be negative 41 or minus 41. So I can take this whole gigantic expression up here and simplify it down to just 15x minus 41. And if you start to kind of think about how much simpler that looks, maybe you can begin to understand why solving an equation, knowing these skills, can be really helpful. Here's another one like that, and I put this one in to specifically illustrate a mistake people sometimes make. So again, here we see that distributive form in the middle, the number multiplied by the thing in parentheses. The mistake people will make is ignoring this minus sign right here. If you ignore the minus sign and just distribute the 3 as a positive 3, you will get the wrong answer. Just like with combining like terms, we need to treat that not as a minus 3, but as a negative 3. And when we distribute, we need to distribute that whole negative. So negative 3 times 6, negative 3 times negative 9. So negative 3 times 6 is negative 18 x's, because there's the x there. And negative 3 times negative 9 is positive 27. And from there, I'm good to go. I can just, again, rewrite the rest of the problem and look for like terms that can be combined. In this case, we've got 4x and negative 18x are going to be like terms. So 4x's minus 18x's is negative 14x's. And here we've got 27 and 4 are like terms, so we'll add those together. And those are going to be a positive 31. So this simplifies down to negative 14x plus 31. And that's pretty much the basics of the distributive property, and you're going to get some practice on this here in a minute, but hopefully it kind of makes sense. Go ahead and give this a shot. For each of these, I want you to simplify them. Just a quick note on the word simplify. It always messes kids up. It really means solve, as basically make it as simple as you can. Don't do one thing and then stop. So in the future, if you haven't heard this, simplify is kind of synonymous with solve. Alrighty, good luck.